In this video we will study about force, which is our next chapter. So we have read that a body which does not change its position with respect to its surrounding is said to be at rest or stationary, whereas a body which changes its position with respect to its surrounding is said to be in motion or a moving body. For example, if this cap is placed here and is not disturbed, it will be placed here. But if force is applied to this and force is applied to this cap and which is pulled from this position to this position, so it now this cap which was kept here is now kept here because force is applied to this cap. Now for example, this pen, if it is left, so you can see it will start rolling because force is applied to this pen. So in the same way, if the body is at rest, it will always be at rest if no external force is applied or no external disturbance is caused to the body will keep on rest. But if the body, as soon as we apply force or we disturb the body, it changes its position. So this is what is called force. So a force is cause, push or pull. Force can only be caused because of push or pull, which tends to result in movement or change in size or shape of a body. A force, when applied as push or pull on a stationary body which is free to move, can produce motion in it, and if applied on a moving body, it can change the speed of the moving body. That is, it can speed up or slow down the moving body. For example, a ball which is rolling, and if you, for example, a ball which is rolling on a plain ground, and if you kick that ball, what will happen? That ball will gain more speed and it will flow in the air. It will change the speed of the ball will change. Force also causes the size and shape of the body to change. For example, if I take this piece of paper, and if I squeeze this, what will happen? What you will see students, you will see that the size and the shape of this plain paper is changed. Now you can see that there are many folds on this paper. So now the shape of the paper is being changed because force is applied to this plain paper. Now here we are having some example which is given in your book. A grass roller, initially at rest, when pulled begins to move. A fielder, when catches a ball, stops a moving ball. A moving car slows down on applying brakes on it. So force can also stop the moving body. For example, when a fielder catches a moving ball, the ball stops in the hand of the fielder. A push on a swinging girl speeds up her swing. A player, when applies a force by his hockey stick on ball, the direction of the motion of ball changes. When force is applied as a stretch or squeeze on a body which is not free to move, it changes the size or shape of the body. For example, stretching a rubber string, its length increases, and sometimes also the string breaks when you apply more force on the rubber string. On squeezing a tube of gum, its shape changes because you have to press the gum bottle so that the glue can come out of the bottle. Thus, we can define force as a force is that cause which changes the state of a body, either the state of rest or state of motion, or it changes the size or shape of the body. So finally we can say that force is push or a pull. Force is a cause of push or pull. It changes the size, shape of the body. It also speeds up the body, and it also slows down the moving body. Now next we have to note some important thing in this chapter is a force does not change the mass of the body. You have to underline this, that force does not change the mass of the body. It only changes the shape, but it does not change the mass of the body. We cannot see a force, however we can see or feel the effect of force. We cannot see force, but we can only feel it. A force is expressed by stating both its magnitude and direction. Now what is magnitude? Magnitude is the amount of force which is applied on a body. For example, there's suppose that there are two person. First person applies force X and second person applies force Y. So what is the magnitude of force? Magnitude of force is the total amount of force which is applied on a body. Total amount of force which is applied on a body, that is X plus Y. This is the total amount of force which is applied on a body. This is called the magnitude of force. Magnitude means the amount of force which is applied on a body. Total amount of force which is applied on a body. And the direction, that is suppose we are pushing this pen in the left hand direction, so it will move to the left hand direction. You can see if I apply this if I apply force on this pen, if you apply force on this pen on the left hand side, it will move to the left hand side. If you apply force from right hand side, it will move to the right hand side. That is, the body will move in the direction on which the force is applied to the body. We'll further understand this in our next topic also. A force is represented by an arrow which is given in your book. The length of the arrow is measured. The length of arrow is measure of its magnitude, and the arrow head shows the direction. So we write force in this way. Now next is unit of force. So what is unit of force? Unit of force is Newton. The SI unit of force is Newton, which is denoted by symbol capital N, which is placed this unit is placed in with the name of the scientist Sir Isaac Newton. Now what is 1 Newton? 1 Newton is defined as the force which, when applied on a moving body of mass 1 kg in the direction of its motion, increases its speed by 1 meter per second in 1 second. This meter per second is the unit of speed, SI unit of speed. Now we will study about what is weight of a body. We have read that our earth exerts each body towards it, and that is why only we are able to stand on the earth, because earth is having gravity. And what is gravity? This gravity is only called the force with which the earth attracts the body towards itself. A force of attraction exerted on a body by earth is called weight of a body, or the force of gravity. So force of gravity means the force with which the body attracts. Force of gravity is the force with which the earth attract the body towards itself. As we have studied that our earth, this is our earth, this is our earth, and it attracts all the body, all the matter which is present on the earth towards itself. It works like a magnet. The surface of the earth works like a magnet, and this force with which it attracts the body, this force is called force of gravity. This is only the force with which, this is the power, you can say, with which the earth attracts the body towards itself. So this is only the weight of the body. This is only called the weight of the body. Now we have the force of gravity is also called weight of a body, is different at different places on the earth. And if you go on moon, the gravity is different. If you go on, if you are standing on earth, the weight of the gravity is different. And if you go on the other planet, the gravity may decrease or it may increase on different planet. At a place, the force of gravity of a body of mass 1 kg is called 1 kgf, that is kilogram force, or 10 Newton. In other words, 1 Newton is the force of gravity at a place on 0.1 kg or 0.1 kg is, if we convert this 0.1 kg, which is also called 100 gram mass, thus the unit of force, that is kgf, kilogram force, and Newton, how they are related to each other? It is related as 1 kgf, that is 1 kilogram force, is equal to 10 Newton. This is we will use in our numerical part. So it says that if we are holding 100 gram weight, we have to exert 1 Newton force, as it is written here. In other words, 1 Newton force, that 1 Newton is the force that we have to exert to hold mass of 100 grams. If we have to hold 100 gram mass, we have to exert force of 1 Newton, then only we can hold that 100 gram mass in our hand. Next we have the another part, that is the turning effect of force. We have read about that if a force is applied on a stationary or a rigid body, stationary body, or you can say a rolling body, it start moving in the straight line in the direction of force. As you can see, if this ball is being pushed, the direction, you can see the direction of force is given this way, and the ball will also move in the direction of force. means both are parallel to each other. That is, force is also being given in this direction. As we can see the example, I am giving force to this pen in this direction to keep on moving in. Force is also given in this direction, and pen will also keep on moving in this direction only, because force is being given on this direction. Force is given on this direction, pen will also start moving on in this direction only. So in the same way, force is given to the ball in this direction. You can say this direction on the left hand side, on the right hand side. So ball will also move on the right hand side. If the force is given this way, this side, suppose the force is given on the left hand side, force is given this side, so the ball will also start moving this side. So it says the body will move in the direction of force. Wherever the force will be applied, the body will keep on moving on that direction on the applied force. Now if the body is not free to move, but it is pivoted means it is fixed to some point, or you can say a body is having axis at a point O and a force is applied to a suitable point A, it begins to turn about the point O. Now you can see this figure. In this figure, a ball is being pivoted, or you can say our axis is being decided in here, and force is applied to this body. What will happen? It will start rolling in the direction of force. This direction of force is called axis of rotation, because it will start rolling, because it is fixed, so it will not able to move. So it will start rolling at this fixed direction. As a earth rotates at its point, in the same way it will start rotating at this fixed position. You can see in this paragraph it is given about this rotation, and the force is applied to a suitable point O. It begins to turn about a point O. The vertical axis passing through the point O about which the body turns is called axis of rotation. In figure 3.3, on pushing the wheel begins to turn about its pivoted point O. Now we are having some example relating to this pivoted point or axis of rotation. Now there are some factors on which the turning effect of the body depends. The first factor is the magnitude of force applied, means how much amount of force we are applying on the body. Larger the magnitude of force applied, more will be the turning effect of a body. And perpendicular distance of a force from a pivoted point, larger will be the perpendicular distance of a pivoted point at which the force is applied from the pivoted point, more is the turning effect. It means that if a body is being pivoted from the center and from here we are applying force to this body, it will start moving, it will start rotating, this body will start rotating. So if this distance, this center and the point where we are applying force, this distance is more, the turning effect will also be more. This is what is being explained in the factor. And the amount and the magnitude of force means the the amount of force which we are using to turn this wheel or this ball which is being pivoted from the center. Now we are having some example, our daily example. The first example says, to open or shut a door, we apply force which is called push or pull, normal to the door at its handle P, which is provided at the maximum distance from the hinges as shown in figure 3.3. Now you can see in this figure that hinges, these are hinges, means these are bolts with which this door is being hung to this frame of the door. So this is working as a pivoted point. This is working, this is the center of this door, and the force from here, the handle is provided for force. In this picture, this is the handle for force to be applied. Now you can see the distance from the hinges and the handle is kept maximum so that the turning effect can be maximum. So this is what is being told in this example, that this distance should be more so that a force or a turning effect can be more and our work can become easy. Now there are some more example. This hand floor grinder which is used in olden days, and also we can see in some of our home in our village that this is being used to grind pulses, wheat, etc. Now here you can see this is a pivoted point of access where the hole is made in the center, and this is the place where we have to apply force, and the distance between the hole and the force is kept maximum so that this can rotate easily and our work can become easy. Now some more example is the potter making clay pots. Same logic is being applied in this example also. Next one is carpenter using a drill machine. The next example is a car steering, bus steering, or any steering which is put in a four-wheelers. Now bicycle, example of bicycle also you can see two circular rings, two circular chains are provided here, and both are being pivoted from the center, and then the paddle is given, and the distance between this pivoted point and the paddle where we have to apply force is kept maximum so that our cycle can move very easily and we can apply less force to move our cycle. And the next example is a spanner to tighten the bolt. You can see here we have to, this works as a pivoted point, and the distance is from this pivoted point, the distance is kept maximum and force is applied here so that our work can become easy. Now the conclusion says, we conclude from the above example that the turning of a body about the pivoted depends not only on the magnitude of the force, but it also depends on the perpendicular distance, that is the distance from the pivoted point of the force from the point of rotation. So larger will be the perpendicular distance, less is the force we have to apply, less is the force needed to turn the body